Okay, so P and Q are two triangular prisms that are mathematically similar. And what that basically means is that the large prism is an enlargement of the small prism. And if we check two corresponding sides, we can see that prism Q is twice as big in terms of its lengths. All its lengths are twice as big as in prism P. So the length factor, we'll call that the scale factor, is times by 2. Now what we're actually asked to do, I've missed it off the question, but we're asked to find the volume of the larger prism. So we need to work that out, first of all, by finding the volume of the small prism, which is quite easy because we've been given the cross-sectional area at the front. And then we need to multiply it by the volume factor, which is not the scale factor. So I'll come to what the volume factor is in a moment. But first of all, let's work out the volume of the small prism, or volume of prism P, simply going to be 10 times 15. If you look at the front of the formula book, you'll see the volume of a prism is area times length of consistency. So that's 150 centimetres cubed. Now, you should know that if the scale factor is times 2, the area factor is times 2 squared, and the volume factor, because we're dealing with 3 dimensions, is times 2 cubed, which is times 8. So all we need to do then is to take the volume of the small prism, which we've already worked out as 150, times it by the volume factor, which remember is 8, 2 cubed, and the answer will be 150 times 8, which is 1200. And remember to stick your unit on the end. That's the answer.